Hello, and thank you for joining us today for the webinar sponsored by ABB Empower, entitled Labor Overruns Are Costly. Understanding Labor is the Key to Estimating Accuracy. My name is Ellen Carson. I'm the Editor-in-Chief of EC&M, and I'll be your moderator today. Before we begin, a few words about this webinar technology. This platform allows our audience to be more involved with the presentation, and more importantly, allows you to watch this event the way you want to watch it. So to begin, feel free to customize your webcast console. You can move windows around by dragging on the title bar, or resize your window by clicking on the lower right-hand corner of any window and expanding it from there. You'll notice a toolbar at the bottom of your console. Those buttons allow you to open and close the widgets on your screen. If at any time you experience difficulties with the audio or advancing of the slides, simply press your F5 key to refresh your webinar console. We always encourage you to ask questions throughout the webinar, so at any time, using the Q&A widget on the left side of your screen, you can add questions at any time through the webinar, and then we will get to those as soon as possible at the end of the presentation when we take questions. We also appreciate your feedback. So please click on the survey icon and complete the form if you have a chance to do that. We would greatly appreciate it. So now let's turn to our speakers. I'd like to introduce today's presenters. Don Kuiper serves as president of Estimating 101, an electrical estimating consulting and training business. With 42 years of experience in the electrical industry as an electrician, estimator, estimating manager, and project manager, he brings the best practices and outcomes for estimating electrical projects. In just over 3 years, Don has provided training for more than 60 contractors and trained more than 170 estimators, project managers, and owners. He is a published author of several books on estimating philosophy and Trimble AccuBid Classic estimating software. He also writes the bi-monthly column Estimating Essentials for us on EC&M magazine. He is a member of ASPE, American Society for Professional Estimators. He holds a bachelor's and master's degree and currently lives in Niagara Falls with his wife of 43 years. They have 4 daughters and 2 grandchildren. Next, we have Will Gunn. Will has been the digital project manager for ABB Empower since joining the team in 2015, just as Industrial Solutions was beginning its digital tools transformation. His main focus is continuous improvement of the Empower experience. So with that, let's begin. I'm going to turn it over to you, Don.
Thanks, Ellen. Appreciate everyone joining us today for this estimating webinar. In my travels in the last 4 years, most every contractor seems to be having difficulty meeting those labor hours they have in the estimate. Many times it's a problem with the estimate. Sometimes it may be a problem with labor productivity in the field with field electricians or maybe management of the project. But one thing for sure as estimators, we need to make sure that we need to understand the fundamental principles of estimating, that we can estimate accurately and assess the labor and the number of hours it's going to take to estimate a project. I received a call about a year or so ago from a contractor in the Midwest, and they told me they wanted to learn software. And he said, we need to learn software better. And then he made this statement. He said, however, every job we've had, we have gone over on the labor. He told me they knew how to estimate. If you constantly are going over on labor, either one or two things, either you're not estimating correctly and accurately, or you're not managing as efficient as you could. So let's jump into these principles of estimating and see if we can help you today. And let me just preface this today by stating, I don't know your company, I don't know your market, I don't know your competition, but I want to share with you these principles, and you take these principles, and if you can apply them to your market and your company and what you do that can help you, I hope that that will take place. So labor overruns are caused by several reasons, and that not limited to these reasons, but first of all, maybe not having enough labor hours in the estimate. Maybe there was a failure to apply the installation labor factors while you were estimating. Maybe there was a failure to calculate the project labor factors. Maybe we had poor project management, and or maybe we had poor productivity in the field by the labor forces. So our object today in this webinar is to help you accurately estimate labor hours and how to focus in reviewing an estimate and checking it to make sure that you have done your due diligence to be as accurate as you can with these estimates. So there's 4 areas I want to go over with you today to help you understand to be a better estimator. First one is understanding labor units and labor columns. Secondly, understanding installation labor factors. Third, understanding project labor factors. And then help you to focus on what matters in the estimate. So the first section is understanding labor units and labor columns. Now this is a screenshot out of Trimble AccuBid Classic software, and I just used it to illustrate. You can see on the left side, this software and most every software allows you to do the same. There are 6 labor columns. There's column 1, 2, and 3 that the contractor can customize, and then there's NECA. Columns 1, 2, and 3 are normal, difficult, and very difficult. And on the left side of that screenshot, you see there are labor units, and these labor units correspond with competitive, difficult, or industrial labor to help you assess the project accurately. So first, let's talk about labor columns. I want to make sure you understand the difference and why you maybe should move from one labor column to another. So labor columns are determined by the project size, the building height, the project duration, and the location of the project. In 1923, NECA published its first NECA manual of labor units, and this labor unit manual was assembled by studies and feedback from contractors at the time, giving NECA feedback. But I do want to preface and make sure I say this. There's no better labor units than what a contractor has studied for themselves, for their own labor, their own foremen, their own project managers. There's nothing better than tracking your own labor on your projects. So NECA tells us that there are 3 columns, column 1, 2, and 3. The first column is referred to as the normal column, which is residential or commercial. The second column is difficult, institution, maybe a school, maybe a prison, maybe some type of institution other than a commercial retail building. Column 3 is referred to as very difficult and or industrial. And most of you in the webinar today, and obviously if you estimate change orders, you know that we use these NECA columns when we estimate change orders, but most of us don't bid projects using NECA 1, 2, or 3. But I want to share with you today of how you as an estimator should look at a project, whether you should consider maybe adjusting these labor units and or moving to an increased column. So again, we have labor columns and we have labor units that we assign to these items. So a NECA 1 labor column, I'm going to give you the description by which NECA, and then hopefully give you a good takeaway to help you understand. So NECA tells us that column 1 is determined by a building that's up to 3 floors, is street level. It's 20 to 100,000 square feet per floor. It's a rectangular square building. It's not an odd, circular, very odd-shaped building, just a square rectangular building. NECA tells us that the building location should be in or near a metropolitan area. And the reason being is there's got to be electrical supply houses. There's got to be a place to get material and transfer what you need to the project and equipment and rentals. It should be outside a controlled access area. It shouldn't be in a prison. It shouldn't be behind say a government building that has clearance securities and a process to get into a controlled area under security. and it would be a single building. NECA 1 column tells us that the construction schedule is a 8-hour day, 40 hours a week. All the work's done on the daytime shift. There's no overtime. NECA column 1 tells us that the project should be characterized by it's a 600 volt power distribution. It's a local utility, all standard UL materials, all the systems, all the lighting, the conduit, everything is installed at 16 feet or less. And then you've got a set of drawings that have good engineering, you've got good design, you've got a complete set of drawings, complete spec, you have a realistic schedule to complete the project, and you are furnishing all the materials for the project, meaning there's no owner furnished materials that you have to coordinate with the owner. Assuming the typical site conditions would provide you with a good supply of qualified electricians. You're using all new material. There's no interruptions, no delays, no jurisdictional disputes. There's no harsh weather conditions, meaning above 45 degrees Fahrenheit and less than 88 degrees. We have relative humidity. I did a project in Buffalo, New York on Lake Erie several years ago when I was estimating for a contractor. And we were to rewire the boat docks around Lake Erie, and they wanted the work done January and February. And we told the NFTA, the Niagara Frontier Transit Authority, we told them this was going to cost them a lot more money to do this in this harsh weather. And they said they didn't care. And we added 40% of our labor hours to cover for working outside in extremely cold conditions. These are real, and I'll teach you that when we get to project labor factors, and we'll talk about that a little bit. So which column to use? So here's what I want you to get from this today is I just characterized for you, based what NECA says, is a column 1 project. Now, when you're bidding something that's not characterized by a 3-story building at ground level in the city, you've got good electricians, you got plenty of them. But if you're bidding a project that's a long ways away from your shop, there's no supply houses, it's a 20-story building, labor pools are running dry, and you're struggling to find quality electricians, you might better stop and think about the labor column and the labor units that you're using to bid that project, because there will be overruns if you're not careful. So let's talk about a labor unit. We talked about labor columns, and basically the labor column is determined by the project type, where it's located. So let me help you understand a labor unit. A labor unit, by definition, is a unit of time for the installation of material. A light fixture is going to take a half an hour. I'm going to install 3/4 conduit at 3 hours 100 or 4 hours 100. I work with electricians that couldn't install it in that amount of time. Some are better and some are take longer. But this is a unit of time that it takes to install some material. So what is included in a standard labor unit? A standard labor unit is comprised of 65% installation time and 35% of non-productive time. Now, non-productive time is actually a misnomer in estimating, but all books are written with this terminology, non-productive. But if it's something you have to do to install the material and do the work, it's truly productive time and must be accounted for. So if you break down a labor unit, it looks like this. 65% is install, 20% of that time is material handling, 5% of that time is interacting with supervision. Now, this supervision in this labor unit is not non-working supervision. This is time that the electrician will interact with the foreman or the project or someone in order to get direction and instructions on where to work, what to do, and what material to install. And then the electrician will spend about 10% of his time interacting with drawings, laying out the work to install it. So a typical labor standard labor unit or typical labor unit breaks down like this. If you break it down in the four components, 39 minutes to install, 12 minutes to handle the material, 6 minutes to lay it out, and 3 minutes interacting with the supervision. This is vital you understand this, and this is why I want to show you. So standard labor units are based on the work being done by skilled, quality, journeyman electricians, not apprentices, not helpers, skilled electricians. So when you don't have skilled electricians, then adjustments might need to be considered in your bid summary when you're summarizing a project for less skilled electricians. You got to have quality people that know what they're doing in installing the electrical work. So many times as estimators, I wore a tool pouch 17 years, worked in the field, project foreman, project manager, estimator. Many times as an estimator, we have to put something in our estimate, and many times we'll think I can install that fixture in 20 minutes, 30 minutes. You're going to assess an installation time. So you need to understand that 65% of a labor unit is installation time and 35% is these other non-productive layout, material handling, and cleaning up and supervision. Therefore, if I thought something would take an hour in my on the project to install, a labor unit of 1.54 is required. And the reason is because 65% of a labor unit of 1.54 equals 1 hour of installation time. So the anatomy of the labor unit would look like this. So 1 hour is 65%, and the other 35% is the 0.54 of the labor unit. So remember, when you're estimating and you have to make a determination about a labor unit for an item, if you're only assessing installation time, you must cover that 35% non-productive time in your estimate. So let's talk about installation labor factors. Installation labor factors, the definition is, these are labor unit adjustments based on the difficulty or ease of the installation. So here we see an electrician working on a scaffold. So obviously if he's taking material and working up on a scaffold at a height, because of the condition of the installation, there must be some adjustments made to these labor units. So there are project conditions that require an increase in the labor unit. Here are some examples: metal stud, masonry, vertical runs. Right? For example, if I'm putting in vertical runs from the first floor to the second floor, from the second to the third, as I move up the building height, I've got to take tools and material with me. So you can't run conduit in a vertical run up a building as fast as you could run it on the first floor across the ceiling space. So there has to be some adjustments because the labor use is going to have to increase on these installation labor conditions. And then, of course, if you're running conduit exposed or fixtures above normal heights. Here's some conditions that cause the labor unit to decrease. If you're putting conduit in a slab, if you're putting it in a trench, if you're putting multiple runs in a trench, or if you have parallel runs, right? If an electrician's running 4 sets of 4-inch conduit, he's going to take one measurement and cut 4 pieces of pipe. He doesn't have to measure 4 times. He's measuring once. So when we have parallel runs of conduit, we can decrease the labor unit because the electricians can install those conduits a little bit faster because they're doing several on the same rack in the same area and only taking one measurement. So if you're doing work in a metal stud wall, the industry standard is around 25%. You're going to have to increase the labor unit. If you're putting conduit in masonry walls, you have to increase that labor unit about 100%. And honestly, it may be more than 100%. But if 3/4 conduit is 4 hours 100, the way you estimate, and you're going to put it in masonry walls working with brick masons, that labor unit for that material may need to go to 8 hours 100 because you're working with brick masons as they're building a block wall. When you're putting conduits in the slab, you're not leveling it, you're not strapping it on unistrut. You're not anchoring it with concrete anchors and strapping it and leveling it and running it perpendicular. Obviously, you can reduce the labor on these conduits when you're putting them in a slab. Put a single run in the trench, you can reduce the conduit. You put more than one conduit in a trench, you can even take more of a reduction on those conduits. If you're working at an increased height, working off of a lift, I'll give you a chart here to show you some. So a 2-inch EMT conduit at a standard labor unit, say, was 8 hours 100, and that's NECA 1 labor for 2-inch conduit. At a 10-foot height, I'm not going to increase that labor unit. But if I'm installing that conduit at 15 feet, I'm going to increase it about 10%. 20 feet, 20%. 25 feet, I'm going to increase the labor unit by 30%. So you can see if I go up to 40 feet, I'm going to increase that labor unit by 50% and taking that 2-inch conduit from a standard typical labor unit of 8 hours 100 to 12 hours 100. So as an estimator, you must understand that there are installation conditions that cause you to make adjustments to labor units. So 3 points of review. Installation labor factors are the application of adjustments based on the difficulty or ease of the installation. This adjustment may increase or decrease the labor unit, and typically with most software programs, I know with Trimble AccuBid software, this labor factors and factoring the labor is handled during the takeoff process of the estimating task. So let's talk about the third thing of our understanding labor. We've understood labor columns and labor units. The labor column is based on the project size, the location, the height. A labor unit is 65% install time, 35% non-productive time. You got to understand there's cleanup and all these things. We've understood that we adjust these standard labor units based on something being more difficult or something being easier. We can adjust those labor units to be as accurate as we can. Now, there's a third aspect of understanding labor to be accurate in producing estimates, and that is understanding project labor factors. We just talked about installation labor factors. Now we're going to talk about project labor factors, and that is, what are the project conditions? So a project labor factor are project conditions that affect labor productivity negatively, meaning your productivity and your production is going to go down. So here's some facts about project labor factors. The first is, project labor factors are labor hours that are added to the direct labor hours total. Number two, these percentages will vary in various markets and in geographic locations. What's applicable in the north may not be applicable in the south. What's applicable on the west coast may not be applicable on the east coast. And so as an estimator, you're going to have to understand these project labor factors for your area, your market, and start tracking it so you can bid accordingly and bid properly. The third thing is labor factor percentage adjustments are cumulative. So we'll see, I'm going to give you a list of several, and all these adjustments you make are going to be cumulative labor hours you're going to add to your estimate. And then number four, typically these labor hours and these labor factors are handled in the bid summarization of the program. Now I'm going to give you 10 critical project labor factors to just talk about briefly. So access to the work area. You got to be able to get people in and out of the project site quickly. The building's construction, the crew size. If you've been in construction and been in project management any length of time, you know as the crew size gets larger, productivity goes down. A project with 4 electricians will have better labor efficiencies than a project with 44 electricians. Everybody knows if a task would take 8 hours for 1 electrician to install, don't be so naive to think 2 electricians could install the same work in 4 hours. It typically just doesn't work that way. So the larger the crew size, there's going to be loss of productivity. The job location, if it's a multi-story building. Number 6, if it's an occupied facility. Number 7, if there's overtime. Number 8, the stacking of trades. Number 9, the staging location. And number 10, weather conditions. So let's look at some of these. So I have on my website, I have a 5-page document that I detail the 24 most important project labor factors with detailed descriptions and understanding it. You can go to my website, and there's a free download that you can get that document, and it will explain these 24 project factors in great detail for you, and it will help you understand all aspects of it. So here's what every estimator must understand. It is the estimator's responsibility to bring to the attention of the chief estimator and or the owner any of these project factors that will be applicable to the project that you're bidding. If the schedule is compressed, the estimator has to tell the owner of the chief estimator, look, we have a compressed schedule because a compressed schedule is going to maybe involve overtime. It may be a large crew. These are all vital and very important factors that an estimator must understand in order to properly bid a project. So let's talk about one of these factors. We're not going to talk about not even all of these 10 and certainly not all 24, but let's just look at overtime, lost productivity. A standard labor unit, I told you back in the first part of the webinar, that a standard labor unit was based on a normal work week. That means it's 5 days a week, 8 hours a day. But when you take a job and put it into overtime, there are several effects, and here are just 5. It's not limited to this. There are many more than this. But every time you have a job that goes into overtime, the labor productivity will decrease, safety awareness will be lessened, there'll be decreased energy levels, workers' morale will decline. You know, a lot of electricians, a lot of estimators like to hunt, like to fish, people like to vacation. If you have a project during hunting season in some geographic locations of the country, those guys, their morale is going to be declined because they don't want to work 12 hours a day, 6 days a week. So the effects of overtime will impact labor productivity greatly. It will be increased absenteeism. So here's a chart based on studies. You can see I've given you 10 weeks, 16 weeks, and several different schedules. And the percentages you see, the loss of productivity increases as the time goes on. So the longer the duration, the longer the workday, the more days you work each week, the greater the loss of productivity. So let me show you here. I've picked the schedule of 6 days, 10 hours a day. This chart is different than the one on the previous screen. What this chart is showing you is a blended percentage of that lost productivity. So I've chosen 10 weeks, 6 days a week, 10 hours a day. You would average every week a 22% loss labor productivity. Let's look at the financial impact of that. So if I'm working 6 10-hour days for 10 weeks, that's 60 hours a week. If I've got 10 workers on the project, that's 600 hours weekly. And if we're going to work for 10 weeks, that's 6,000 man hours. At a blended lost productivity rate of 22%, I'm going to lose 1,320 hours of just the work is just not going to get done as fast. At a blended labor rate of $75, now you would have to calculate this in your market, and I know there are various markets that use various labor rates. There's prevailing wage projects and there's non-prevailing rate. But at a $75 an hour labor rate, just on 10 weeks for 10 men, it's almost $100,000 financial impact. I don't know about you, but where I come from, $100,000 is a lot of money. And so if you've got a project and you're going to be working overtime, you better analyze and take a look at that lost productivity. Again, for your area, your company, your electricians, it may not be 22%. It may be 18%. It may be 15%. But I can rest assure you this, it is some percent. It is not zero. And so addressing the lost productivity of overtime in an estimate is vital. So let me ask you, you got some electricians working on a transformer in extreme cold. What does that do to the work, the labor hours, and how much we get done in a day? Got a project and it's extremely hot in Dallas, Texas, Phoenix, Arizona. What do workers do? They're going to cool off. They're going to stop and drink water. A lot of people around that opening in the ground, a lot of cranes, a lot of lifts, stacking of trades. You got a lot of workers in a condensed space. I've been on projects like this, and the crane operator has said, everybody get out of the way. We got to make a lift. You got to get out of the hole, and so your productivity is impeded. So these are all real losses that take place. How about a multi-story building waiting for an elevator? Preparing material for the crane to lift and set up on the roof of the building or set on the 20th floor. These are all things that take time and extra time that must be accounted for when we estimate. How about working night shift? You got a project that goes on a night shift that you got to get work done in the evening. How about access to the site? I've bid a lot of FAA runway projects. I've bid projects where the runway was going to be active. And so you would go out on the runway, do work. You would be notified you got to get off of the runway. These are all project conditions that affect the labor productivity negatively. So the estimator must assess it. How about an occupied facility? How about an estimator who had to replace this? You had to estimate the time to replace those light fixtures over that produce in this grocery store. What is that going to take? You have to cover up that produce. You have to clean up after. You have to get your tools out of the grocery store. All of these project labor factors, impact, have to be accounted for. Hours have to be added. I think I need to find a new slide for Sears. I don't think too many Sears stores are left. But suppose you were bidding a department store and you had to replace all of those recessed fluorescent fixtures, LED fixtures. You're going to have to cover up that clothing rack with cloth and drop cloth. You're going to have to vacuum. You're going to have to move the tools and material off of the retail store floor space. All of this takes time. All of this impacts your labor negatively. Project labor factors are conditions that affect labor negatively. So we got to understand the labor column. We have to understand a labor unit. We have to understand the ease or difficulty of the installation at 40 feet in the air or putting it in a slab. We have to understand, is it on the 30th floor, right? One of the things I do, I vet and screen estimators for contractors. And one of the test questions I ask them when I do, I say, what would you labor a 2x4 lay-in fixture? And most of the time they'll say 0.65, 0.75. And I don't tell them, but I write down on my paper to review with their prospective employer. You know, if you're an estimator and you really understand the fundamentals of estimating, here's the way you would answer that question. Don, I can't answer that. I need to ask you, are there 3 fixtures or are there 3,000? What is the ceiling height? Is it a 9-foot ceiling? Is it a 19-foot ceiling? How high is it to the deck above the ceiling that I have to tie the fixture off? Are these fixtures on the first floor or the fixtures on the 30th floor? Are the fixtures in a brand new building or the fixtures in a building that's occupied that I have to do on third shift? These are all vital questions that an estimator must understand about assessing labor when they're bidding a project. So let's talk about the fourth part of our webinar, and that is understanding how to focus on what matters. Now, focus is the center of activity, the attraction, and or attention. It is a focal point of concentration. And so as an estimator, you must understand how to focus on the parts of the estimate that truly matter. Right? Let's suppose a sound speaker and all the sound system only makes up 0.5% of the total labor of the project. There's no need to have a meeting to determine what we should labor sound speakers. It's probably not going to affect your overall estimate in a very significant way. But let's suppose your conduit work is 60% of your estimate, then you might need to take and look at that conduit a little more closely. So let's look at focusing on the estimate that matters. So in focusing it as an estimator, let me make this statement. There's two major steps in estimating, and that's quantifying, that's the counting and the measuring of taking drawings and specs and counting and measuring all the material. After an estimator has counted and measured and put it into the software or written it up on paper or put it in an Excel spreadsheet, however you estimate and whatever software you use, after that, being a good estimator is understanding percentages. You must learn to focus on the percentages or the percentage of the project or the type of project to help you produce a quality estimate. So let's look at the focus and let's look at the percentages by project types. Let's talk about commercial work. Commercial work, 60 to 80% of the branch of the labor on a commercial project is branch wiring. So focus on accurately estimating the branch wiring, because that branch wiring is going to contain the majority of your labor hours. So you got to make sure you get that right. When I say branch wiring, I'm talking about the 3/4 and the 1/2-inch conduit for the lighting, for the convenient receptacles, for the fire alarm system, the sound system, the data, all the small conduit. All of these labor hours are going to make up about 60 to 80% of your labor hours. If you go to retail space, it goes to about 90%. And if it's an existing retail space, it may even be 95%. Because a retail space that's existing, the service is in place, and you're just going to change some lighting, a cash wrap, and there'll be very little changes. That will be the majority of your work. Water treatment plants, I have a heavy industrial background, Class 1, Div 1, explosion proof. Water treatment plants, wastewater treatment plant, about 85% of the project's labor is in site power, distribution, duct banks, feeders, and generation for the project. So what I'm saying to you is when you're estimating, you have to learn to take the project type and determine where the largest percentage of the labor is so you can assess it and so you can make sure that you've estimated it as accurately as you can so you can have a good competitive bid that's going to allow your company to make money. In gas and oil work and plant gas work, 50 to 60% of the project's labor is in tray and tray cable. There's going to be lots of work pulling tray and putting up tray and pulling cable. So let's talk about branch wiring and focusing. So in commercial projects, it's 60 to 80%. In a water treatment plant, it's 5 to 8%. So in a water treatment plant, branch wiring wouldn't require as much as my attention as it would on a commercial project. In an industrial plant, it's 10 to 15%. Obviously, I would look a little closer at that. Again, I'm looking by the type of project where the majority of my labor may be found and make sure that I've estimated this as accurate as possible. So let's talk about labor cost codes or labor percentages. This is a screenshot from Trimble AccuBid Classic software, and this is on the extension screen that I've grouped it by the labor cost codes or the labor sort codes. So I have 12 sort codes here, and the way this works is these 12 sort codes is how the project is going to be built. Number one, I'm going to rough in the conduit, boxes, coring. I'm going to cut and patch and paint. I'm going to install cable tray. Number 4, I'll do some outside civil work. Number 5, I'm going to pull some wire, feeders, pull the branch wiring, and follow the sequence all the way down till I get to line 11 and 12, where I'm trimming out, putting in devices, and putting in the aux sensors on the project. Okay, so in this portion of the webinar, we're trying to learn to focus on what matters when it comes to labor. So you'll notice the far right column says labor, and it gives you a percentage. So those numbers on the far right column of this screenshot gives you the percentage of what each of these labor codes are of the total labor in the project estimate. So I've identified 3. So these 3 labor categories have a combined percentage of almost 82% of my labor. So here's what Don Kuiper is saying to people that estimate. You better analyze your conduit labor, your wire pulling labor, your fixture labor, and make sure you've estimated that accurately, because that's 82% of your labor. So you have the ability to take this, depending upon your software, and you can make adjustments to that labor. So in Trimble AccuBid Classic, I have a labor adjustment column that if I think my labor risks are too risky, I can increase that labor of just that labor category if I want to. So I can take that labor category of installing the conduit, and I can include an adjustment of 20%, 25%, and minimize my risk, cover my labor hours to make sure that I'm estimating as accurately as I can. Let's analyze and focus on systems. When we estimate, right, we break down our estimates by system, by site lighting, site power, the lighting, by the feeders, by the branch wiring, and you can see that I have 15 systems here in this estimate. This is an actual estimate that I did. Okay? So what we want to do is, as an estimator, we want to focus on where it matters. So I've taken those 4 systems and I've added up, and the total labor in this estimate, and this was an actual estimate, this is not make pretend, I didn't make these numbers up. These 4 systems equal almost 65% of my total labor. So here's what I'm saying to you when you estimate. Look at the site lighting. Make sure it's as accurate as possible. Look at the lighting. Make sure it's as accurate as possible. Look at the branch wiring. Make sure it's as accurate as possible. Look at the data. Make sure it's as accurate as possible, because those systems are going to comprise 65% of your labor. And then we look at material categories. So I've grouped it by the material categories, not by labor. I want to look at the money of the labor material dollars, and I've identified the top 2 categories, conduit and fittings and the cable and the wire. Those 2 material categories alone equal 84.19% of the total material cost in the project. So as an estimator, I got to make sure that I get those right. I'm going to look at the items with the largest totals. Again, I have the ability with this software to do a sort descending. So I have 23 items that I've identified that the total cost for each of those items is $500 or more. If I have an item and I have 2 of them in my estimate that totals the material dollars of $10 or less, I don't have to spend a lot of time chasing down a price for something that's that small. But I want to identify the items that comprise a lot of the cost. So the result of this estimate is I had 317 items in my estimate that total $60,000. The top 23 items equals $46,780. So those 23 items comprise 78% of the total material cost. So here's what Don Kuiper is saying. The top 23 items are only 7% of the total items. So make sure that you have the proper price on these items, because those top 23 items are going to make up a lot of your material cost. So wrapping up what we've said today is 4 areas. Number 1 is make sure you select the appropriate labor column and you assign the appropriate labor units. Apply the installation labor factors. Make sure that you properly calculate the project labor factors, the percentages, and the duration. And then learn to focus on what matters in the estimate. Learn to focus by project type, the labor cost codes, the material cost codes, the systems with the largest labor percentages, and where the material costs are. So now I think you have the key to preventing labor overruns as an estimator. And having a good quality estimate will help you. Understanding labor is vital for the estimator. Thank you very much.
Great, thanks, Don. And now this is Will Gunn here. I'm just going to take over, just for a few minutes with a quick video here on a slightly different topic, which is, our ABB Empower tool, and then we'll open it up for Q&A. So for those of you who don't use it, aren't authorized users today, Empower is the online tool that's used by ABB customers to view and order products. So if you order from an ABB distributor, they're using Empower to fulfill that order. And our focus here is always on productivity. So that's why we have an audience here. Want to make sure we take just a couple minutes to highlight some work going on in this space, because we know that little things can add up, and efficiency is really the name of the game. So with that in mind, a new feature that we have in our Empower tool called Panel Scan, it's an opportunity to make the folks who are using Empower, generating quotes, specifically doing panel board configurations, much more productive, which makes it quicker turnaround time for things like budgetary estimates, quotes, things like that. So I won't go through all the nitty-gritty here. What I will do is show just a quick video, but at a high level, Panel Scan is a tool you see on the left-hand side that automates the process for panel board takeoff. So we take an offline manual process today, and we've automated that through essentially, machine learning, AI, kind of buzzword sounding, but that really is what it does. It allows you to upload your document. If you're an Empower user, somebody who's preparing quotes, upload your document, let the machine do the work that the machine is good at, which is getting this, the panel board information, the breakers, all the details. Let the human do what the human is good at, which is review those panels, validate and add them into their quote, and then do all this work in bulk. So essentially what we want to do is take that takeoff process, automate as much as we can, and just ultimately make people much more productive. Our goal is always for ABB to be the easiest one to work with, and that can be, get quote back, cycle time, things like that. So in the middle here, you'll see Panel Scan was launched to general availability over this past summer. So any distributors who are using Empower Quote, any ABB sales folks who are using Empower Quote have access to Panel Scan. And so far what we're seeing is upwards of 90% accuracy per document, and that's across, you can see some of the numbers there, thousands of documents, tens of thousands. This data is probably 2-3 weeks old at this point, so probably even closer to 100K on some of those now, of what we've processed through the system, as well as continuing ongoing improvements here through some of that feedback loop of the machine learning. So I'll show just a very quick video here on what Panel Scan actually entails and where some of the benefits are, and then we'll turn it over to Q&A. So let me just click play here on this about 2-minute video, and you should hear the audio coming through your speakers.
Oh, hi. You caught me at the least favorite part of my job, the paperwork. So I'm all over anything that's easier and saves time. That's why I'm a big fan of Empower's Panel Scan. It speeds up quotes and ordering. Now pages of panel schedules that used to take me hours are done in minutes. I can respond to customers faster and cut down on the errors caused by tedious data entry. Sound too good to be true? Here, let me show you how it works. I simply upload PDFs of my job specifications. I can do it one at a time or in bulk. Panel Scan pretty much does the rest. This blue check tells me the system got it all. These specs worked because they're clean and logical. If your specs are unclear, blurry, handwritten, or covered with coffee rings, Panel Scan probably won't be able to read them. And here they are, the panel schedules Panel Scan automatically created. The system identified all the panels from the job specs and created all the line items from the schedules. All that's left for me to do is give it a human proofing to make sure it's right on. Let's take a look. This panel schedule has a yellow pending status, meaning I need to validate it. When I compare it to the input document, I see it's missing a breaker. I simply point and click to add it. I approve the schedule, the status turns to green, and I move on to the next one. Checking this next panel configuration, I see the schedule is perfect. If I see 5 or 6 of these same configurations are perfect, I can approve all the panels with this configuration automatically. It's all about saving time, freeing up resources, and getting it right. This first generation of Panel Scan understands the most common panel schedule formats. ABB is continuously adding more panel types based on what they see. And they tell me Panel Scan actually learns and gets smarter the more it's used. My customers like it too because I can be more responsive and get them accurate quotes faster than anyone else. That's an advantage for both of us. Its intuitive design is easy to use from day one. There's also a quick training module. ABB actually came by my place and gave us hands-on training in no time. Panel Scan works for me, and it can work for you. All you need to do is upload, validate, and approve. Panel Scan does the rest.
Great. So hopefully everyone was able to see that video. Just a quick example of some of the technology and digital investment that ABB is making. Again, the goal is to be the easiest one to work with here, and make it as efficient as possible, make everybody as productive as possible. If there's one thing to take away from here, it's that I know some of the folks who are on this call maybe aren't in Empower using it every day or anything like that, but providing panel schedules to distributors or ABB folks that you work with, there's now more powerful tools to hopefully turn things around quicker, get you back quotes and all that kind of information a lot quicker. And you can help by providing clear, detailed documents and really just encouraging people who you're working with on the ABB side to use that tool and kind of get that feedback loop going. And again, our goal you see on the right-hand side, we're committed to this. This isn't something we launch and walk away from, but continuous work to increase the types of formats and then next generations of this tool to make it even more powerful. So far we've seen pretty good results, quicker turnaround time, and our ask out there is for anyone who's interested in the ABB partners you're working with, push them and reach out if any questions, and we're here to again make everyone more productive. So with that, I thank everyone here for sticking around. I'm just going to advance the slide here once more, and we will go into Q&A.
Okay, hi, this is Ellen back online. I'm going to go through some questions, but first I'd like to thank our speakers, Don and Will, for a great presentation. And before we get into the specific questions, I'd like to remind the attendees that some people had asked questions on the Q&A panel about certificates. If you'd like to receive a certificate of attendance for this event, you can click on the green resource list button at the bottom of your screen. And then if you click on that, you can download a certificate. So if anyone's interested in that, that's how you do that. So let's take a look at the questions. We've got a few minutes here to do questions. If we don't have time for all of them, we will definitely make sure that Don and Will can follow up with you later with answers to anything anyone asks. So keep your questions coming if there's something you'd like to ask. So let's take a look at this first one. It looks like it's directed for Don. Don, someone's asking about, are these labor tables available for reference and where?
Labor tables.
Yeah.
of course, NECA, the organization of NECA, provides a labor manual. But if you're estimating with estimating software, most all major brands of software have all of these labor units built into the software that can be customized by the contractor. Now, the percentages based on the installation labor conditions and percentages for labor factors, those all have to be determined by the contractor themselves.
Okay. Let's see, something similar. Is there a link for the project? Please send the link for project labor factors where you would have a negative impact on your labor costs. Was that something in the slides, or is that something we could send out?
That link on my website under the free downloads is a 5-page document that gives detailed information about 24 project labor factors and how it affects labor productivity. That's on my website.
Okay.
Now,
right,
again,
on the free download section.
Now, there's no percentages there. The percentages have to be determined by the contractor based on the geographic location, the market, the competition. That's something that I know of. No person, no company, no estimating source that I know of sets any of those percentages for a contractor. I think you can find some suggestions, but I try to stay away from very specific percentages. I think the contractors will be best served determining their own.
Right, that makes sense. Someone else is asking, is the overtime productivity chart on your site as well?
No, it is not.
That's something we might be able to send out after the presentation. Someone is asking, how do you know if your estimating program has accurate labor units? So how do you know if your estimating program has accurate labor units?
The only way to know whether you're estimating with accurate labor units is to track your own labor. One of the biggest failures that contractors make is they fail to track their own labor of how long it takes conduit to be installed, fixture to be installed, because labor units are only suggestions in labor manuals. The only way to know whether they're accurate is if you're checking it against your own company. There's no other way.
Okay. What is the importance of accurate project cost codes with respect to labor factors?
The importance of labor cost codes, I probably couldn't emphasize. I probably couldn't emphasize this enough. I'll state it this way: any contractor that fails to track labor by cost codes and how the project is being installed, all they will know at the end of the project is that they went over on labor hours, but they won't know why they went over on labor hours, and they won't know how to fix it in their estimating department. Unless you're tracking labor in the field of conduit work, wire pulling work, feeder pulling, fixture installation, switchgear, unless you're tracking this of what it's taking, there's no way to correct it in your estimating software or in your estimating department unless you track it from your own company. Okay.
Someone's asking an application type question. He's asking, what do you say about a range of estimator experience? So he's given an example. You have like an old hand or a veteran who goes to office with a physical limitation versus a bright young guy with a great computer, but minimal time on the job. So I guess he's just asking about how do you compare those two types of estimators?
Well, first of all, we have to understand any young person or any person that's good with a computer, that doesn't make them an estimator. I illustrate it this way. I could teach somebody how to use a hammer and a saw and a table saw, But Don Kuiper couldn't teach you how to build a house because I don't know the principles of building a house. But to be a good estimator, I don't care if you're young or old, you have to understand the fundamentals of estimating in order to be a good estimator, these principles. Software will not make an individual an estimator no more than the best carpenter tools make somebody a carpenter.
Right. That's a good point. It looks like we have quite a few more questions in the queue, but we are out of time for today's hour-long webinar, and we want to respect everyone's time there. So what we will do is we'll make sure Don and Will can answer all of your questions, and we'll get those back to you at a later time. We'll follow up with those. So at this time, I wanted to, before we sign off, thank our presenters as well as our sponsor, ABB. And I wanted to remind everyone that this webcast will be an on-demand version, will be available if you want to come back at any time for 1 year. So there will be a link to the recording. It'll be sent to you via email in the next 24 hours. So thank you for your questions. We'll definitely get to the rest of those. It was a great presentation, great information, and I want to thank you so much for attending and hope you have a wonderful rest of your day. Thank you.